Before we can start making a data graph, we need to have data. The easiest way to input data is to use some kind of spreadsheet program. You can then save your data as a .csv file. This saves the data as one row per line with columns separated by commas. We will check to make sure that our data is an appropriate file format by using the file print command in Mathematica. We use the insert file path menu item to locate our file and give the file print command, which will return the contents of the file. The first line is our header, or column headings, and the data are in the remaining lines. We now import the file into a variable named data, and we use the import command, where the first argument is our location of our file. We copy and paste from our file print command. And our second argument is header lines, and give it a value of 1. That tells Mathematica that there's one header line that should be removed before storing our data in the variable. We now plot the data using a list plot command. This gives us a very simple and basic data plot. We will adjust the plot style, like we've did with our models, adding a frame, adjusting the plot range so that none of the data points touch the frame in any place. We can clearly see all of them. Add a frame label, a plot label, adjust the image size to be 800 pixels wide, change the base style to be 18 point, and change the plot style so it's blue and larger points so we can clearly see them. We now want to fit our data to a quadratic line model. We use the Nonlinear Model Fit command in Mathematica to do that, assigning it to a variable model fit. The first argument is our data. The second argument is our formula or our model. In this case, it's 1/2 at squared plus initial velocity times time plus an initial position. The third argument is a list, which tells Mathematica what our unknowns or our fit parameters will be. In this case, it's acceleration, vi, and yi. And the final command tells Mathematica what our independent variable is, in this case time. We can now extract the best fit parameters using the following form. We use the model fit command, which is a new command based on the nonlinear model fit, and give it the parameter best fit parameters. This returns the best fit or the measurands for our three fit parameters. We also want the uncertainties. To do this, we use the command model fit, and this time we give it the option parameter errors. These three numbers are given in the same order as the best fit parameters and our 68% confidence interval fit parameters. We can now plot this fit using the plot command. We plot the model fit as a function of time now, where time goes from 0 to 2 seconds, and Mathematica will plot our model using our best fit parameters. We now want to combine data and fit models. First, we re-evaluate our data plot, this time giving it a variable name P1 equals the list plot. Then we will return back to our model plot and assign it the variable P2. Once we've done both of those, we can simply tell Mathematica to show P1 and P2 separated by a comma, and it puts both the model plot and the data plot together. Because we put the data plot in the first position, it used the formatting from that plot. Finally, we would like to add a legend to both plots. We return back to our data plot and add plot legends in this. We placed a point legend about 90% to the right, 90% up, and give it the label data. We return back to our model plot and give it a plot legend as well. It will be a line legend and placed in the same location, about 90% to the right, 90% up, and we'll call it fit. Once we've evaluated both of those, we can return back and reevaluate the show command, and it will show the data and the model fit both on the same plot with legend clearly indicating which plot is which.